So my name is Aaron Williams. Yes, I work for MapD. MapD is a extreme analytics company. And that means we look at very large data sets, and we look at data sets that need answers very quickly. And usually those two things are incompatible. You can either do things quickly or you can do things on a large scale. But we've actually implemented our own SQL columnar database from the ground up that runs on GPUs instead of CPUs. And that's what gives us the massive speed at the massive scale. I'm guessing, everybody in this room knows what a GPU is, right? There's no confusion there? Yeah, okay, good. Whew. So GPUs, though, massively parallel, right? So it turns out SQL queries are easy to turn into massively parallel instructions, and that makes it fantastic to run on GPUs. We typically get about 100x speed improvement over running similar queries on similar sized data sets versus CPUs. So for our customers, it's typically two problems they're trying to solve. One is you care about the difference between 200 milliseconds and 20 milliseconds. There are some hedge funds where that means millions of dollars in difference. And then there's other customers that want to be able to put the data at the very largest scale in front of as many of their analysts as possible. They want to be able to use all of the data now for making real-time and interactive decisions within their company. The core database itself is 100% open source, so you can go to GitHub today and take a look at the core database. We love the fact that we have an open source database with a community built around it that can help us make that really strong. So what I'm going to talk about today is being able to use that core database inside tools like Jupyter to be able to enable a much bigger, a much larger workforce to be able to take advantage of these new improvements in data. And all that was just my picture slide. So everybody knows who this guy is? Yeah. I'm sure the guy before me knows. So that's Satya Nadella, right? Our favorite CEO. I love this quote, and it's actually, it's probably been said 100 times in 100 different ways, but it's basically the software eats the world quote, right? Software is eating the world. Software is now the thing that companies compete on. It's not good enough just to create a great product. You have to have great software that runs your company. And I believe the same thing is true for data. Data is now eating the world. And I would just make one small change to his quote. Like, it's done. Like, it's over, right? It's not something that will happen. It's something that has happened. And especially when you think about it in terms of data, data now has become this interesting competitive weapon. We've spent about the last decade, maybe 2 decades, collecting all of that data. That was the first problem we had to solve. Then we created the problem of how do we make that data actionable? How do we turn it into something that we can actually use to make decisions? And now we're into a mode of how do we make it predictive? How do we make it so that we can take data today and use it to figure out what's happening next? And so we believe that new technologies are needed in order to be able to solve that entire end-to-end problem. So we created MapD. Now this picture, does anybody actually understand this picture? So this picture is really detailed. And usually I've got about 45 minutes to go through it with somebody, and I know I don't have that here. So I'm just going to be very quick. The database at the bottom is the piece that's open source. That is what runs on GPUs and leverages GPUs. You can go get it today and use any of the interfaces we have to the database to be able to use it for free as much as you want. What we offer to our customers is a thing called Immerse. It's in the upper left-hand corner. I'm going to show you what that looks like in just a second. But that's basically what data analysts would use for interacting with that data. And on the right-hand side, we have what data scientists typically use for interacting with that data. And this goes back to my original hypothesis that what we want to do is provide multiple tools, the right tools for the right user so that they can be most effective at interacting with the data. And I'm going to show you one example of that. So typically, how the data scientists will interact is using an interface called, there you go, PyMapD. So we've created our own Python interface to the MapD database. This is also open source, of course. You can go and take a look at that for yourself. I'll just open the docs real quick so you can get a sense. It's very simple to install, very simple to use. This is kind of the starting point. Of course, you can use this inside Jupyter Notebooks, and I'll show you an example of it in just a second. But this just gives you sort of the entry point into how to connect to the database. Of course, we offer other interfaces to the database as well. So SQL is probably the #1 database, which you can use through a lot of different languages. ODBC, JDBC. We also offer specific APIs for doing things like charting and rendering. I'll talk about why we offer that in just a second. But this enables you to build more complex applications on top of MapD. And I'm excited about sort of where we're going to be going with that in regards to Jupyter. We want to be able to embed those visualizations directly into the Jupyter notebooks, and we're working on that right now. OK, so let me just jump in and show you a quick demo using our Immerse tool. Why am I using our Immerse tool? I think this does a good job of showing sort of what most of our customers use this database for. First of all, very large data. This is 13 billion rows worth of shipping data. I assume I don't have any boat captains in the room, although you never know in Boston. But 13 billion rows. Basically, every boat, every ship in the US has to send a ping back to the Coast Guard about every half hour, and that ends up sort of building this massive database worth of ship data. If I click on passengers here, what happens is I get a cross filter across all of that data. What just happened there was the web page did 4 brute force SQL queries across all 12 billion rows and returned 4 results in about 300 milliseconds each, and that's going to California and back. The reason that's interesting is because that gives me now full interactivity on very large data sets. I can actually interact with these different charts. I can interact with the data in a whole new way that I typically could not do before. Probably the chart that's the most interesting is the one on the left-hand side, the map. This chart actually contains all now 630 million rows worth of data. If I hover over any given point, I can actually see the data for that point. And that's just, again, an individual query that goes back and returns that individual piece of data. This is what makes it possible now for what our customers do, which is typically have a team of data scientists that are sort of responsible for managing the data, prepping the data, getting it ready, producing the algorithms and other machine learning tools, doing the training, for instance, that's necessary. But then, as much as possible, pushing that data and the interaction with that data out into as many hands as possible. So one sort of simple anomaly you can see. So if I go look at the passenger ships that are relatively large, again, 4 more brute force queries across all of that data. I can easily move this around and force it to make more and more queries if I want. You can see the seasonality of cruise ships, basically, is what this comes down to. These are passenger ships. You can see in the winter, massive drop in the number of cruise ships. No cruise ships in Alaska in the winter. Probably no surprise there. So I'm not showing you anything that's terribly exciting, but from the standpoint of being able to come across and stumble across these kinds of variability, this kind of variability in the data, this is what our customers are typically looking for. The ability to take 12 billion rows, turn it into 3 million rows, which are the 3 million rows I care about, and produce this kind of data. We also have another example. This is about 380 million rows of Twitter data. So the most recent 380 million tweets. These are just the ones that have a geolocation, a geocode associated to them. So we plot them on this awesome looking map. We can sort these by language, for instance. Again, quick sort to give us just the ones that are in French. The interesting thing about this, and suddenly, no, there it is. The interesting thing about this, I think when we sort by languages, you can see actually these languages are pretty universal. Like, it's not the case. You would expect to see like France and maybe Montreal would light up, but it turns out like French is everywhere, and you can barely see it on this screen, but you see all the dots that are kind of like all over the place? Like, this was one of the weirdest things when I first did this. Like, if you hover over this, you'll see that there's this dude who just like tweets this weird stuff, and he has this like algorithm for what the tweet is. Like, if you go look on his website, you can see what that actually means. It's a code, basically. And he just tweets all over the entire world, puts a random geocode in with his tweets, and tweets it out, and assigns and puts the French tag in with his tweet, and just keeps doing this like over and over and over again. But the weird thing to me is it's not actually just, at first I thought it was just French, but if you take off French, you'll see like he actually does every single language all over the entire world in this weirdo code. This guy's my hero. Like whoever has this much time, like That guy's just awesome. So anyway, weird anomalies, right? The other thing that if I take off that filter, if I go back to all 390 million, you'll also see that there's another similar example of that up in Finland, actually. So see how in Finland, this purple box is actually just a rectangle? It's not, doesn't look like it conforms to the... Oh, come back. Well, I'll let you explore that for yourself. It's scintillating, let me tell you. No, actually, there's a guy in Finland who tweets every Finnish number, and then he tweets actually the spelling of the Finnish number. And the reason he does it is because Finnish numbers are like really, really long. If you want to spell out the number for like 10,000, it's like this really gigantic word. And so I think he's doing it kind of as a joke, but it's kind of cool. So if you go there, and he also tags a random geolocation within that rectangle to it, so you can see all of every Finnish word. Anyway, okay. Finding anomalies in data. That's really what sort of this kind of interactivity enables, something that across 390 million or up to 390 billion rows would typically be impossible because you couldn't interact with it. Each query would take hours to run, and therefore it wouldn't be something that felt interactive and wouldn't be something that you would try things on a lark to see if you could figure them out. Okay, that's my quick demo. Let's jump back to a couple slides, and then I'm going to show a couple of notebooks. So the reason this works is because of how we handle memory inside the GPU and outside the GPU. When you load data into MapD, you're actually loading it into the CPU first. We load all the data into the CPU memory. Then, when you actually run your first query, we load the columns that you're querying against up into GPU memory. And so what that means is we don't actually have to put the entire database into GPU memory. We only have to put the stuff you're querying against into GPU memory. Turns out, probably no surprise if you know GPUs, it's the GPU memory that is the bottleneck. It's having the amount of memory that you need to be able to store all of the data that you're querying against. And so it's this sort of memory management model that becomes one of the most interesting things about MapD. It's the reason why having a database built from the ground up to run on GPUs, instead of taking one that may already run on CPUs and sort of having it leverage additional hardware, we're still usually 40, 50 times faster than those other examples because of sort of thinking through how the unique parameters of what it takes to run on a GPU. This also means, by the way, that typically we are not the sort of store of record. People don't use a GPU database as their sort of standard database. What they'll do is typically pull in the data they care about, that they want to be able to have this interactive query against. It could be all of the data. It could be, you know, hundreds of billions of rows, as I say. But typically, they have all the data sitting somewhere else in their data warehouse, data lake, whatever you want to call it. And then when they're ready to do the querying or to offer this as a service to analysts or to decision makers, they pull it into a specific MapD instance that folks can get access to. So this brings me to the GPU Open Analytics Initiative. And this was kind of the whole point of the talk, but I wanted to kind of give you a little bit of background into where we came to get here. This was founded last year by us with Anaconda and H2O, and also with NVIDIA, of course. We're now, I think, maybe a dozen companies and open source projects are involved. The whole point here was, once we had the data in the GPU memory, we didn't want to have to pass it back out to CPU memory and then pass it back into GPU memory in order to be able to do interesting things with it in a GPU. We realized there were a bunch of different technologies that wanted to access that GPU, that memory, that data in GPU. And so it was better if we just kept it in GPU and used Apache Arrow to pass a pointer to that data around to these different things that wanted to have access to it. And so we created that. We created the GPU data frame about 9 months ago, I think, now. It's in active use, so you can go out and take a look at the GPU Open Analytics Initiative GitHub, and you can see a bunch of examples out there. I'll actually show you one because I think it's pretty good at... So this is where you're probably going to get started. You can download the Docker container for MapD. You can also download Docker containers for the other sort of components, H2O AI and other components. So typically what you'll do is actually use MapD as the underlying data store, upload your data into MapD, and then run your training models against that. And this example kind of walks you through how to do that. It's all using PyMapD as the Python interface and using GoAI as the means of passing that data around between the different functions. So it shows you how to, in this case, all you're doing is importing a data into a GPU data frame and then using that in a few different contexts. There's another example out here where we actually upload the New York City taxi data set, a pretty famous public data set, into MapD, and then use PyMapD and PyGDF to run some machine learning algorithms against it. So these are pretty comprehensive kind of first steps into how to start to use GPU databases. Anybody here actually have a GPU like in their data center that they use on a daily basis or a regular basis? Yeah, yeah, a few of you do. So one of the big problems we have is it's actually hard to get your hands on a GPU right now. So if you actually go even to NVIDIA and say, dear NVIDIA, please give me a GPU, even if you're like a company that they might have invested in, perhaps, like MapD, it's actually hard to get your hands on a GPU. Good news is Azure and Amazon and Google have plenty of them that they're happy to sell you on a per hour basis. And so my recommendation is, and you can follow the instructions that are out there today, go get yourself set up inside an instance in one of those, in your favorite cloud. Put MapD onto that instance, get your other algorithms and machine learning tools, toolkit, whatever is in your data science tool bag, get it all up and running inside one of those and give it a whirl. I have some AWS credits that Amazon was nice enough to give us. Bezos is such a nice guy. And so if you don't have access to Amazon, but you'd love to give this a try, you can send me an email or see me afterwards, and I will make sure that you get some credits where you can go try it for yourself. It's about 90 cents an hour, I think, right now for the single GPU boxes on AWS. And they have a single GPU box, 8 GPU box, and a 16 GPU box. So anybody here need a 16 GPU box? That would be awesome. I would love to talk to you if you do. OK, anyway, sorry. So this is where you get started, though. There are examples on the PyMapD, in the PyMapD repository for just how do you actually use PyMapD to talk to MapD. And then there's more examples inside the GoAI repository where you can see how to actually get the whole kit up and running and how you can actually run their machine learning algorithms against it. OK. So I talked a little bit about that. This is where we're so excited, because today we think that this enables kind of a new thinking about the machine learning pipeline. And this is, I was happy to see on a previous slide something very, very similar. And probably not a whole lot of argument, I hope, around sort of what that pipeline generally looks like. But I think the interesting thing that we've seen with our customers is how it's not actually usually a single persona that is responsible for that entire pipeline. And so we have one customer, for instance, it's a telco. They collect an inordinate amount of data, you'll be shocked to hear, from all of your phones. They're collecting information about where you are and what you're doing. They're collecting information about what apps you're using. They're collecting information about, very simple information about the sort of signal between their towers and all the phones. All that data turns into hundreds of billions of rows of data per day, so it's an inordinate amount of data. The thing that they were challenged by was they used to have sort of a centralized team that was responsible for that data and, frankly, responsible for answering all the questions about that data. So they had the responsibility of producing reports and producing answers to the company. What they realized was that's untenable. It doesn't actually scale to the point they need. So now they have that team just responsible for making sure that data is put into a format and into a tool that is appropriate for each person that needs to have access and how they need to have access to it. So that means we've got some people using a tool like Immerse for being able to go in and do that interactive exploration of the data. Then you've got other people using tools like Jupyter to go in and actually run much more scientific, much more sort of deep machine learning, deep learning type exercises. And that's where I start to get excited. It just means that we've got this sort of continuum of different tools, this continuum of different ways of interacting. And that's why I think having a platform like what we've produced with GoAI gives us the ability to be much more flexible when it comes to how you interact with that data. but still be efficient with it. Keep it on the GPU, make it possible. I talked a little bit about the different machine learning examples. So I put this here because all these slides are out on SlideShare, by the way. Sorry, I should have told you that at the beginning. All these slides are out on SlideShare. So if you need to, you can go out and get them there if you want to go back and look through any of these links. But there's GTC is next week. It's NVIDIA's big annual GPU Love Fest in San Jose. I'm going to be showing an entirely new demo with Volkswagen using churn as their data set. So they have a very large data set of, hey, do these people that have Volkswagens come back to our service centers, or do they go somewhere else? And what they want to be able to do is predict against their customers which ones are going to come back to their service centers and which ones are not. And so we've done a whole sort of analysis of that. If you go look today, mapd/mapd/ml demo, you can actually see the scripts are already up there for that demo, and there's pretty good documentation for sort of what it is and how it works. We're going to be recording the session next week at GTC. So if you ping me end of next week, or maybe the beginning of the following week, I'll be able to send you a link to that, and you can get a look at that as well. The reason I love that is because it starts to turn the conversation towards things that are much more tangible from the standpoint of being realistic out in the real world. How would people actually put this into use? I think it's one of the big challenges that we've had over the last year, maybe 2 years, is finding really tangible examples of how this is used. And so I think, I'm hoping that over the course of the next year, that's all I'm going to be showing and all I'm going to be talking about are these much more tangible examples, starting with VW next week. So next steps. I can tell, just by looking at you all, when the snow comes tonight, you're going to be sitting under 8 inches of snow playing with mapd. Am I right? Am I right? Yeah, see, I knew it. So this is where you start. We have a really active community, community.mapd.com. Come ask questions, get engaged. All of our engineers actually participate in that, so happy to have you come and talk with them directly if you have questions about sort of the use case that you have in mind. All the demos that I showed are available. They're running now at mapd.com/demos, so if you want to go to pretend to be a boat captain and you want to play around with 13 billion rows of ship data, have fun. It's available for you to do. You don't have to install anything. Just go there and start playing. Definitely go check out the repos that I showed with the Jupyter Notebooks and sort of how you would actually connect using PyMapD and using the PyGGF. And last but not least, if you want to go get MapD, we have a community edition that's available for free that includes everything you've seen here today. And you can go and download that. We have it available as a Docker image. We also have it available as an AMI. You can get it running in Amazon just at the snap of your fingers. And that's it. I think I made it with like 2 minutes to spare.